All right, welcome back to Diesel Talk. An oldie but a goodie. 6.0 Power Strokes. A lot of things going on with the 6.0 Power Stroke, even to the day. I would say that even to the day that 50% of our work is the 6 liter. We get a lot of 6 liters still coming in. A lot of people that don't know much about them. A lot of miles on a lot of them, but a lot of misconception, misunderstanding about 6.0. So I thought I'd have a little series talking about the 6 liter. So there's a lot of misinformation. I actually made the mistake of joining 6.0 forums and groups on Facebook, and there are times I just want to pull my hair because these guys are just, I don't know where they're at. So hopefully some of this information will help you out. So let's keep moving on here. So here we go. The 6 liter is a 32 valve direct injected turbocharged engine. Duh, some of you guys know that. The injector is better known as the G2. It was originally manufactured by Siemens, but now Pure Power seems to have all of it. So you can now buy a brand new injector from Pure Power, and there are also reman injectors such as those available from Ford, Alliant Power, and so on. So we have our favorites. I'm not going to lie to you, but the fact that I can get a new injector is a good thing. So it's got a variable geometry turbocharger. Speaking of new parts, yes, you can buy a new turbocharger, not reman, a brand new one from Garrett and any distributor from Garrett. You got cast iron heads. That's also available new, isn't it? So, and then you got your glow plug system, which many trucks run around with that check engine light on because of the glow plug. Quick note, is a glow plug an emission control device? The answer is yes. It reduces cold start white smoke along with allowing for proper startup, especially in cold temperatures. So there you go. Those of you may or may not know that the 6 liter was manufactured by International, which is International Truck and Engine. There is a Super Duty Excursion, and then there's the F650 750 base 6 liter engine. So what am I trying to say is, as it says on the bottom, there's a VT365. For those of you that don't know, many people call it the 6 liter. You could if you want to, but it's International's version of the 6 liter. There's a lot of differences, though, a lot of differences. So I wouldn't call them the same motor. To me, there's the VT365, and then there is the 6 liter used on Ford products. So there you go. So if you're dealing with an F250, F350, F450, F550, those all use the 6 liter. Now, the F650, 750 at those model years, there was an option. There was the option to have a VT365. There was an option to have a Cummins 5.9, and there was also an option for a cat motor in them too. So you can have any of those three back in the day. Now, why is this important to understand? Because if the truck has like an F650, 750, has a what you call a 6 liter, it's really a VT365. What is probably the most important thing? Well, like it says there on the bullet, the F650, 750 uses the Diamond Logic system, which is International's software. Okay, one thing is Ford software, one thing is International software. So can I use a Ford scan tool on a F650, 750 with the VT365? The answer is no. I would have to use International software in order for that to work. So there you go. So when we're talking about 6 liter, let's get to the nitty gritty. Okay, very important to understand. The 6 liter uses the G2 injectors, like I just mentioned, but it also, you got to understand it's HEUI technology, and they hate to use HEUI. There were lawsuits about that between Ford and International and CAT. Who cares? The bottom line is, for me, it's a HEUI system because it uses hydraulic pressure to pressurize the fuel in the injector itself. So anytime we talk about HEUI, HEUI is hydraulic electronic unit injector. That means we got oil pressure pressurizing the fuel in order to inject. So therefore, on a 6 liter, typical 7-to-1 ratio, we see roughly 3,100 psi coming out of the nozzle of the injector on its base oil pressure. In other words, roughly 500 psi of oil pressure. So let's go over it. When we see the center, we see that the heart of it running is the injector, given the understanding that we got good compression in each cylinder. So let's not forget that anytime we diagnose, and when we get an older truck, we like to sell the customer a compression test, because we want to know where is the compression overall. Because when I diagnose a truck and it's a first-time customer, I don't know this guy, I don't know the truck. It's like me walking to a dark cave. I don't know what I'm going to find. So what's my dark cave here is I need to open it up by looking at what is the compression. So yeah, we will sell a compression test if need be, depending on the situation, especially if it's a high mileage engine. Now, when we look at the G2 injector, once again, you need fuel pressure. Let's start off with the easy one. Okay, fuel pressure, if you got the Blue Spring upgrade, it could go from 55 to 65. Originally, back in 03, 04, it was 45 PSI, but now you should have about 55 to 65. If not, you need to upgrade to the Blue Spring. There you go. Now, you also need the oil pressure coming in, which we call ICP pressure, injection control pressure. Now, that injection control pressure starts at the oil pan. Yes, it starts with oil at the oil pan. If you don't got adequate oil, those 15 quarts that this engine takes, 15 quarts, then it ain't going to work properly. So one of the key things we like to do when we do drivability diagnosis is we check the engine oil level. Very critical to check engine oil. And in this case, we need to have those 15 quarts. Yes, we have had many trucks come in through the years where there was just no oil on a dipstick, 5, 6, 7, 8 quarts low. These people just abused it, and all they needed was oil. So yes, oil is critical. So it starts off at the oil pan. Now, at the oil pan, we got our upper and lower oil pan, which feeds up to the front cover where the oil pump is at. From the oil pump, we go up to the reservoir. There is a reservoir underneath the oil cooler. And then finally, it reaches the high pressure injection pump. So there is a regular engine oil pump, which feeds the high pressure injection pump. So in this case, the high pressure pump, then at that point, we'll go to the G2 injector through a series of plumbings, which we call the oil rails and everything else, which we'll show you here in a bit. Now, there is a dump side to this. We're going to dump pressure. That's where the IPR comes in. Injection pressure regulator. So in this case, that regulator, all it does is opens up and dumps the oil pressure down to the oil pan generated from the oil pump. So the high pressure oil pump, or HPOP as they call it, is pumping, 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 pumping. So it's not variable displacement. It's always displacing depending on RPM. So in this case, what keeps it in check is the IPR valve, which is all computer controlled. Now, this high pressure oil generated by the pump can go over 3,100 PSI. It can go really high pressure. So in this case, I know that we said 500 PSI according to the books, but that is regulated by the IPR. That's why, as I will show you here after this slide presentation, we're going to look at desired ICP pressure and actual ICP, because people often ask, well, if this injector has a job to do, what is the pressure supposed to have, that ICP pressure? Well, it all depends what the computer desires. Now, the computer don't take it lightly, because you got to understand something. If you do a cold start, whether I'm in LA, whether I'm in Florida, whether I'm in New York, Colorado, whatever it is, different altitudes, different temperatures, you're not, doing anything to the pedal. You're just turning the key and boom, it fires up. So the computer looked at all its sensors to know what the actual ICP pressure should be. And that's what we're looking for. That's where the ICP sensor comes in. This is a sensor, injection control pressure sensor. That one gives feedback to the computer to know what the ICP pressure was. So therefore, in this case, it says, hey, it's 600, it's 800, 1200, 1500, whatever it is, it's reporting back to the computer. So it has been known to be a bad sensor sometimes. In other words, not always 100% reliable, but it takes a while before it goes out. So if you're looking to maintain your truck, and the truck's pretty old, one of the key sensors you want to go after is the ICP sensor, very critical, along with the IPR sticking. Now, just a quick sidebar here. In order for this engine to live a long life, engine oil is critical. Okay, I own a 6-liter 2006 6.0, and let me tell you, I change oil religiously and haven't had problems with a lot of these components due to the fact that I change the oil frequently. So there you go. We'll talk more about that in another presentation. So we covered the ICP pressure there. So again, oil comes from the oil pan to the oil pump to the reservoir, the high pressure pump. So if we're doing diagnosis, you cannot blame any ICP pressure issues unless you confirm the oil pump is generating enough oil. A lot of problems out there, like I showed in a previous YouTube presentation, has been the oil filter and oil filter caps. I prefer to stick to the OE design, which is the Motorcraft oil filters and caps. If you see a don't cap on top of the oil filter, that's a red flag that somebody may not have or has messed around with the bypass valve that's on top of that stand tower that's in the middle of the filter itself. So, but regardless, this is our high pressure side, so ICP. So the injector needs high pressure oils, and we see that it has fuel pressure coming in, and finally it needs a pulse width. Now that pulse width is generated right here. This would be our computer. Yes, I left it white blank. This where my cursor is, hopefully you can see it. That is our computer, our PCM, powertrain control module. Well, this guy right here is your FICM. This would be our FICM. So the PCM will send a synchronization message to the FICM, which will turn into a FICM sync. So one of the things you're going to confirm is the computer needs to know, even though you got the crank occurring or the key is on, it needs to get input by two primary sensors, which is the crank and cam sensors, which is the CKP and CMP. All you have to do to see if they're responding is just look at your sync pit. And the sync pit is no reason saying yes or no. Yes, I'm getting the sync. No, I'm not getting the sync. So if you're looking at your scan data or PIDs, parameter IDs, you're going to see that it reads yes, even under a cranking condition. That's what you're looking at. In turn, that'll give it to the FICM. The FICM will respond with a sync message back, FICM sync, and then it'll put a pulse width towards the injector, which is about 48 volts. Okay, 48 volts, and that's something we could look at the scan tool. So, starting over. In order for this engine to fire, if I'm diagnosing, these are the bare minimums I need. So if it does not start, there's something else going on, connections and so on, but you got to look at your codes too. But these are the basics. I need high pressure ICP pressure. I need compression. I need 55 minimum of fuel pressure. And I need a sync message yes and a pulse width going towards the injector. So I can see all of that in the scan tool. So let's keep moving on.
All right, when we are testing a 6-liter, we went over the high pressure system and we went over the basics of operation. So here's the most typical data that I like to use when diagnosing a 6.0. First of all, you'll notice on the top, we got our sync messages. These sync messages are for your crank and cam synchronization. So sync means that we are getting an input from both. And FICM sync means that the FICM itself, the fuel injection control module, has received that signal. The other two that are very important as well, they're all important, but is your ICP pressure and your ICP desired here. So in this case, when you do a crank no start or you are doing a diagnosis under load, it's a good idea to observe both of them. So we're going to go ahead and fire up the engine. In this case, you'll notice the pressure climbed on the ICP. So in this case, we see 580 desired, and we're pretty close to 580. The ICP sensor is always going to be changing, and the IPR is going to be working with that too as well. So here you can see your IPR of 22.65%. Now this engine is pretty cold. We usually like to see somewhere around 30%. So in this case, the IPR is normally open. The higher the duty cycle, therefore, it's trying to close it. So 100% duty cycle would mean that the IPR is closing to create more pressure and thus not have so much bleed off pressure there. That's what we're trying to say there. So, but you'll notice we have sync messages right there. Sync, they're all reading yes. So if you were to be doing a crank no start condition, you would want to look at the sync messages, see what they're reading. And in this case, the primary one you want to look at is the sync, which should read yes. Another thing you also want to be looking at is your voltages on your FICM. Typically, we don't like to see it drop under 45 volts. So in this case, we look for that kind of voltage there. So if it starts to break down under load, or you start to give it some, in other words, APP angle, you try to put your foot on it, you shouldn't see it drop under 45. Some people say 43, but I like to see no less than 44 to 45. That's what I like to see. So let me give it some throttle. And as I go ahead and give it some throttle, you'll notice that we're seeing the ICP pressure desired increase, and the ICP pressure follows it right along. So in this case, that's one of the key things you want to look at. And you'll notice it's all working well, one behind the other. Now, if you ever run across, because one of the things I talk about in training to technicians is that you need to look at voltages. And what I mean by that is signal voltages. Here we could see the ICP pressure we just said, but here we can see the ICP voltage. That can fool you at times because the truck can run with the ICP sensor disconnected. So if you don't have Scan Tool Professional and you suspect you got an ICP sensor problem, simply just disconnect it. So therefore, if there is a problem, what's going to happen is that it's going to be reading 0 or 5 volts or just 0. So if you see that kind of reading, no matter what you do, that definitely means we got a sensor or a circuit problem. Most likely the sensor, but maybe a circuit problem there. So what am I looking at? Well, I'm looking at battery voltage. I'm looking at, as we call it right here, and I'll highlight it for you. This is, as it says on the bottom, is logic power. Oops. we're looking at logic power fuse from the FICM relay. So that's FICM relay. So here I can see 13.16, 13.26, and then it's rising, and there we could see our FICM voltage from the relay. One of the key things I like to tell guys that if you ever do have a bad FICM, what you want to do is you want to go ahead and replace the relay with it, the FICM relay as well, because that can develop resistance. This is a 2006 truck I'm working on, and how old is this FICM relay? You know, how many times is it turned on and off? So can it create resistance in the contacts of the relay? Yes. So here we can see 13.25, 13.5, roughly a quarter of a volt voltage drop is what I'm seeing here. So if it's greater than half, then at that point we should be replacing the relay. But again, make it a habit. If you are replacing the FICM, definitely replace the relay as well. And we just looked at our FICM main power, which is what the injectors are using. I told you, no less than 44 to 45 volts. And then you got your FICM power that's actually from the ignition switch. So in this case, it's pretty damn close to battery power, as you can see from the dot. Okay, so I understand, going back to ICP pressure, injection control pressure, I understand that the books say you need 500 minimum to fire. If I'm doing a crank no start diagnosis, it's got to be whatever's desired. So as I crank it over, you know, I want to see that pressure as well. So let me turn the engine off again, leave the key on. It's going to eventually drop. And in this case, we see 0 desired. As soon as I crank, you know, I'm going to see it. 662 is what I saw there, and then it came up to roughly 660. There you go. So in this case, that's what we want to see. Now, if I were on a test drive, what I would be doing is that I'd be actually watching the 2 bar graphs right here, and you know, as I go ahead and give it throttle, and you can notice I'm giving it throttle, giving more throttle, and we see the pressure go up and down. So that's your injection control pressure. So like I've been teaching for several years, please make a note. How do I diagnose ICP pressure? Is you look at the desired versus the actual. So there you go. So once again, sync messages, battery power, your FICM powers, your ICP actual and desired, and you could watch what your IPR is doing. So here we could see 23%. And in this case, as the engine warms up, I'm going to be looking for that IPR probably to change a little bit that duty cycle. But remember, like I said earlier, I know I'm repeating myself, IPR is what? Normally open. So we energize it to close it. So 100% would be what? It's actually closing more. 23% means it's closing less. So therefore, it would have to close in order to start the engine. So there you go. Let's keep moving on.